Yeah.
Okay, so do you want to continue revision?
Yes, please.
Okay, so yes, exterior, interior. So you've done bearings. I just was able to get more of these. Yes, so bearings, maps and scale drawings, constructions, loci, symmetry. We did that one. Yes, there's one little thing in this that I wanted to make sure of. Okay, how do we do this?
Okay.
Any idea about this one?
So do you need to also draw a line for like y equals to 0?
Yeah, and that's basically just the x-axis.
Yeah. And then so I'm not really sure how to explain it. Do I need to say like so
So I would just do the transformations.
you guys so for shape Q, do you need to do one square after the line x equals to -1?
So this
And
is
then,
this is 2 away from it.
alright, sorry, so 2A.
Yeah. So
And
that's
then it needs to look opposite to like P as well. Like mirrored.
to give Q. Yeah. So that one's 1, 2, 3, 4. So that's 4, and that one's 5. Okay, so that's shape P,
Yeah.
and then
And then because that's one square above y equals to 0, do you need to then draw shape R one square below y equals to 0?
yeah. So then, oops. And then same thing, reflect that.
Yeah.
And the one thing I wanted to check was describe the single transformation.
Um,
That maps shape P onto shape R.
is it just like an 180-degree rotation or
Yeah. And one more thing you have to say. You have to say center of rotation.
uh, oh, do I need to take the coordinates of the point as well? Or-
Yeah. Of the center of rotation.
Okay, so is the center of rotation for P 2, or
2, no. So, let me just see. If I was to join these up, would that do it? So if I was to join up these two corners, and then join up these two corners, yeah. Where do they cross over?
they cross over at -1.
Yeah. And so that's the center of rotation.
Oh, right.
So what do I need to say? Center, and its rotation 180 degrees. Yeah, so you do this double reflection, and then they say describe the single transformation instead of this double transformation, and it's just as one transformation, it would be a rotation 180 degrees about the point minus 1, 0.
Okay.
Any questions about that?
No.
Okay, so they sometimes ask you to do two transformations, and then they say what one transformation would achieve the same thing. Rotation 180 degrees about minus 1, 0. Okay, how about this?
So describe what is it? Okay, so shape A is being rotated 90 degrees anti-clockwise,
Mm-hmm.
and for the center of rotation, do I need to join up the top point of A to the top point of B,
Yeah.
and then like one of the left, like the left bottom point of A with like the left bottom point of B?
Okay. They didn't cross over. Oh, sorry, that one is it? That's the right. Sorry, that'll be there, I think.
So the center of rotation like 0, 3.5.
I don't think so. Hang on. Where does it look like it would be? It looks like it's kind of 1, 2 or something, is it? Where else? So if we put those two, that's those two. It's those two. That's there. Maybe it is 0, 3.5. Oh, 0, 1. Rotation, anti-clockwise 0, 1. And how do you know it's through the point 0, 1? You just don't. You just check different points with your tracing paper.
Okay.
So just actually, just trace over this and then just try different points and start with the origin.
So what does center of rotation actually mean?
So that's where if you were to put your the point on your pair of compasses down, and you could say like rotate about that point. So first you could try putting the sharp part down on here, and then rotate stuff to see if that worked.
Yeah.
So it's kind of difficult to show it. I'd say just look at a video for it.
Yeah, I got you.
But yeah, it's where the share point goes with the tracing paper. I think you're okay for these. So what does it look like the center of rotation is for this one?
Is it the top like? Is it 3?
Yeah, it looks like it's 3, 3.
Yeah.
And yeah, 3, 3. So hopefully they're more like that. Yeah, you can kind of see the center there. Okay. I think you're fine for these. Okay, how do we do this?
Okay, so if the axis of rotation is 0, 1, do you then need to draw 1 point, like 1 point of 0, 1, and then?
So you would basically just trace over this. Put your trace paper down. You would trace over this shape A.
Yeah.
Or let's just say the 3 corners. And then you'd put the sharp part down on 0, 1, and that's where you would spin the tracing paper around. So that goes 90 degrees clockwise. I don't even... Okay. And then how would you do part B? Or triangle B?
So do you just take 1 point from B, and then you go like 3 to the left, and then 1 down to give triangle C?
That's it. B is at 1, 0, 1 minus 1, and 3 minus 2. 3 minus 2. Okay, so this is where B is. Up. And then you go 3 left, 1 down. 1, 2, 3. And 1, 2, 3. So what single transformation maps A onto C?
So A is rotated 90 degrees clockwise, and do I just do the centre of rotation thing again?
Well, that would be a single transformation for this one. I don't think it's one rotation will do it.
Okay, so
Is it a reflection maybe in this line? So that's 1.5, so a half and 1, that works. Then this one is 1, 2, 3.5, so a half, 1. No, I don't think it's that. It was close. 1, 2, 1, 2. One transformation that does that onto that. Oh, it is a rotation. One rotation, 90 degrees. So it's just a different type of it's just the same rotation, just about a different center.
Yeah.
Okay. So it was still a rotation, 90 degrees clockwise, and it was just about a different center. And they said it was 2 minus 2. So you just try different spots that make that happen. Okay. Not easy. Enlargements. How about this one?
Okay. So for enlargements, do you talk about like scale factor?
Yeah.
Okay. So I think the scale factors from P to Q is 3.
Okay. I'll just write it down somewhere, so that's worth a mark. And I suppose, what type of transformation is it?
Is it a translation?
No, that's if it is just a slide. Here it got bigger.
Oh, so enlargement.
Yeah, so that's also worth a mark.
And do I need to take one coordinate from P and then try and match with Q?
So this is, yeah, the time where this thing will work. I was hoping it would also work for the other one. So that, they don't cross over. Let's see. Oh, I know what you have to do, sorry. You have to extend it all the way. So let's say the two bottom left corners. You just extend it all the way. And then let's say these two corners. Extend that all the way. So where is the center of enlargement.
Does it start from 0?
Yeah. And so you say center 0, 0.
Okay.
Enlargement scale factor 3, center 0. Enlargement scale 3, center origin. Yep. Okay, this one.
Okay, so seems like another enlargement.
Yeah.
And here, say it's 2 to 3. Is the scale factor 2.5?
Yep.
And then do you need to draw like those long
Yeah.
lines?
And so you just match up the corners with each other. So is that like that? They might like the origin. And so center.
Is it just center 0 again?
Yeah. There you go. Fine. Okay, how do we do this?
So I'll say scale factor 3. So does that mean that so it needs to have 9 squares across and like horizontally and vertically, and then with like from the bottom left point, do you need to do like start it from the same bit for A as well?
So but you have to say where it's going to go to. So if I just did that, let's say.
Yep.
Where's it going? There. Say, is that? Hopefully it's about that. And that one goes through there. But you have to say where will the other triangle be? How do you do that? So with enlargements,
Yep.
not only does the shape get bigger, but the space also gets bigger. So one way you could do it is you could say from, let's say, A to X.
Yeah.
So that's 2 right and 1, 2, 3 up.
Yeah.
And so after a scale factor of 3, where is that going to be?
So do I need to just times the 2 vertically times 3 and the 3 horizontally times 3?
Yeah.
And then so would it be 6, 9?
Yeah. And so from A, it's now 6, 9. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 6, 7, 8, 9. And that's, we'll call that X dash or X prime, like the new X. Okay, same thing for Y.
So for Y, I need to go 6 across and 9 up.
For Y, how far away is Y?
Oh, from the new X.
No. So now do the same thing for Y.
Oh, is it 2 to 1?
Yeah. And so where's Y dash?
So will it be 6 to 2?
1 times 3?
3.
5, 6. So 3 up. 1, 2, 3. And that might be enough for us. In fact, even one point might be enough. But let's see. So how far away are these two? So it should be a difference of 6. 1, 2, 4, 5, 6. Yeah, so they're 6 away from each other. In fact, you probably only need 1 point, and then you can go from there. And we know the base. So what will be the base of the new one?
So, will it be 9?
Yeah. So yeah, so I think all you need is the first point, and then you go from there. Yeah, so to get the first point, you can just do like as a vector or something like that. So you just figure out the space and then do it that way. Let's check. So that's what it looks like. Yeah. Any questions there?
No.
So let's try. Okay, let's try this
one. Okay. So do I need to label each point again?
Let's just do 1. So let's pick the easiest one.
Okay, so will that be the one just above it? But no, just above A.
Yeah.
And that's just 2 up.
That's got a B or something. Okay, and so
Is that 0, 2?
Mm-hmm.
And so do I need to do I need to now enlarge the shape, or
Well, where will this point be after the enlargement?
it'll be at 0, 6?
So it will be 6 up instead.
Yeah.
So 1, 2, 3, 4, 5, 6, and so now that's probably enough to just do the rest of it normally.
Okay. And then for BG to go 3 up.
Yeah.
And then 4 across.
It was 4 across.
Oh, sorry, 12 across.
Yeah. And
then is that 12 across?
Yep.
Oh, sorry, so 12 down, I mean, not across, down.
It wouldn't be 12 down. How many is the thing down?
Oh, 9.
Yeah. Yeah.
And then 3 across.
Yeah.
And then I just need to draw in that line up to be.
Yeah. Well done. Well done. Yeah, so you just have to get, so you know that like you're multiplying all these lengths by 3, and so you just need to know where it actually goes, and so you just find 1 point and then you can use that.
Okay.
So let's just do one more if we can. This oh, that's a good one. Okay, let's try this one. Yeah, it's a great one. Hang on before we do that one. See, I picked these too well. Yeah. Okay, how about this?
Okay. So center 1, 2. So do I need to find how far the center 1, 2 is from like B?
Yep.
So So for the bottom left point, it's 2 across.
Mm-hmm.
So does that mean the scale factor is like the 0, no, 2, 0, or scale
Right.
factor?
And so, go on.
And then does that mean that I need to start from? So does that mean I need to enlarge that by 3?
Mm-hmm.
And so it'll become 9. Oh no, so 6 horizontally.
All right. And so where will this blue point be? I'll call it point A. Where will that be in the new one?
Does that need to be 2 points to the right or something? I'm a bit confused.
So let's call that first point X. So X to A is 2, 0. Basically 2, right?
Okay.
So after the enlargement, what will it be?
6, 6, 0.
Yeah. What's the coordinates of that?
1, 2.
So that's X. What's the coordinates of the new A?
Well, that should be 6 to the right.
Yeah. And so what's its coordinate?
Is it 9, 2, 4?
It's 6 to the right of X, not 6 to the right of A.
Oh, so will it be 7, 2? 7.
Yeah. Well done. So that's the new A, and then you go from there. So maybe I'm being too fancy with vectors. Basically, this one here is 2 to the right of the center.
Yeah.
And so the new one will be 2 times 3 to the right of the center.
Right. Okay.
That's all it is. And then you would just draw the rest of it. So the base is 2. What will be the new base?
So the new base will be 3 times 3. So 9 upwards from that.
Yeah. And base?
And then it'll be 6 across.
Yeah. And then last one you get for free. Yeah, that's it. So from the center of enlargement to this corner, there's a space of 2. And so 2 times 3 is 6. And so now this from the center to will be 6.
Okay.
So don't think about that too much. Okay. So now I have to... Okay. How do we do this?
Okay, so if the center is 0, 0, do I need to find from 0, 0 how to get like from 0, 0 to get to A, which would be 2 across and 2 up?
Yeah. Yeah, okay.
And then do I need to do half of 2, 2?
Mm-hmm.
So it'll be 1, 1.
Yeah.
And then after that, so if the center is 1, 1.
Center is 0, 0. What point is that 1, 1?
P.
Okay, so that's 1, 1.
And then because it's half scale factor, so I mean it has to be 2 across.
Yeah.
And then 1.5 up.
So 1.5 up. So let's just actually use this thing.
Yeah.
So from there, that's going to be 2.5 and 2.5. So it's going to be there. Okay. And what did they ask for?
The area of triangle PQR.
Oh, sorry, they called it PQR. Okay, so what's its area?
Is it 2 times? Is it 2 times 1.5 divided by 2?
Yeah.
And so 3. Or what? No. 1.5.
1.5. Yeah. Oh, well, it's not centimeters squared, just whatever square units. 1.5. Well done. Let me leave that. Okay, how do we do this? Strange one.
Okay, so okay. So if I go to -1, -2, and then if I find out how to get from -1, -2 um, to 1, 1. So is that 2 across and then 4 up? 4.
Mm-hmm.
And then scale factor is -0.5. So if I do 2 times -0.5, it's so -1 and -2.
Yeah.
And then with that, do I then need to do so from -1, -2? I need to go -0.5 up for each one. Oh no, wait. So because it's -0.5 scale factor, so it needs to go down.
Okay. To where?
So does it need to go 1 down from C?
No, you already worked it out. So -1, -2 from C.
So alright, so 1 down and then 2 left.
Other way around.
So one up from 2 right.
No. So the first one, so it's 1 left, 2 down.
Alright, sorry.
Yeah.
And then
from C. So it's 1 left, 1, 2 down.
and then 4.
So yeah, so this is all backwards. Maybe if we were to do it like this, would that be easier? So you know the way we have the center here?
Yeah.
So we might be able to do something similar. So let's say this one over here. And then that would be halved. Would that be a quicker way of doing it? Or would you just have to do vectors for everything? Is there a quicker way with the ruler? So the center is there and the scale factor is -0.5. Okay, so what would be the... Sorry, go on. I think just do all of them like the way you did that point.
Okay. Um, and then for so for that point, and then I need to go do minus a half times 2, which is -1.
Why are you doing minus a half times 2?
I'm trying to get the horizontal, like the bit on the left of the shape of the right.
So let's just pick another point. So let's say this one is B. So do the same thing again for B.
So so what? So from C to B,
Yeah.
and that's 2 to 6.
Okay.
And then times minus a half is -1, -3.
Okay.
And then so does that mean that from C I need to go 1 left and 3 down?
Yep. 1 left, 1, 2, 3 down.
Okay. And then do I need to do the other points as well now?
Yeah.
Okay, so for C to that one, yeah, the one like there, it'll be is it 10? Oh no, sorry. So 7 across.
So from -1 to 5?
Oh, 6. And then um uh is it 4? Oh, okay. And then times minus a half is -3 -2.
Yeah.
And then if I go from C, 3 left, 2 down.
3, 1, 2. Yeah.
And then am I allowed to just plot all the points now?
So you could plot those 3. Any idea where the last one would be?
Would it be would it be like so minus a half times 4, so -2. So would it be 2 down from D?
Yeah. So that one is 4 up from D. So this is 2 down from D. Yeah. I need to join those up. So it's just not. It might be. It's all backwards because it's minus. Yeah. Any questions there?
No.
Okay. So I think, yeah, go there. So that's similar. I'll get to that in a second. Yeah. Yeah. Okay. Time for similar. Okay, how about this?
Will that just be like 4 times 5?
Yep,
So 20.
that's it. So that's just 20. Okay, how about this?
So do I need to just work out the area of both trapeziums and then mine subtract it from each other?
Yeah.
So the formula for area of trapezium is like half a plus b times height,
Yeah.
and then um, so so will the b be 6 centimeters?
Will what be 6 centimeters? Sorry?
So will a to g be 6 centimeters?
Let's see. So A to B is 7.5. So what's the scale factor?
1.4.
Isn't that 1.5?
Do I need to do 7 divided by 5?
7.5
Oh, sorry.
divided by 5. So that's 1.5.
Yeah.
And so the scale factor is 1.5. And so how do you use that?
So scale factor is 1.5. So does that mean that for so trapezium AEFG is an area of 36 centimeters.
Mm-hmm.
So do I need to do half a plus b times height equals to 36?
So we can't possibly know like A and B and H. And so what you would do is you would just enlarge the area to get the big area.
Oh, so 1.5 times 36.
So it would be that if 36 was a length, but this is an area. So area scale factor? Centimeter squared?
Do I need to do 1.5 squared?
Yeah.
Okay. So
what is that?
it says here it's 81.
Okay. And so shaded region.
So do I need to do half a plus b times height?
No. So 81 is the total area.
Yep.
36 is the white area.
So if I just do 81 minus 36, I'll get the answer.
Yeah.
Okay. So 45.
Yeah. Let's see. So because you don't have enough sides, you can't possibly do a half a plus b h, and in fact you don't even need to. You can use AB and AE to get the scale factor, and then you just do small area times scale factor squared to get total area, the big area, and then find the difference for those.
Okay.
So that's 45. 1 second. Let's see. Okay, how about this?
Okay, so the scale factor is 2. So do I need to do 2 squared times for the volume or something?
Volume isn't squared.
Oh, cubed.
Yeah.
So do I need to just do 2 cubed times 160?
We want the volume of B?
um, so do I need to use the formula of a cone?
No. What is the volume of A?
171,700 centimeters.
Yeah. And so it's that area enlarged by the scale factor cubed.
Okay. So so 1,373,600.
Okay. And there you go. Yeah. So it's just small volume times scale factor cubed gives you big volume.
Okay.
We did this one before. Yes. So hang on. Value of x. Okay. The length of each day. Length. I think I went past it. 1 second. Yeah. Okay, how about this?
Okay, so do I need to do so 300 divided by 120?
Mm-hmm.
No, because that's different, isn't it?
Yeah, it's different, sorry.
So do I need to do 120 divided by 20?
Yeah.
Which is 6. And do I need to do 6 squared times 300?
Yes.
And so that is 10,800.
10,800. Well done. So that's good. You've got the hang of that. See if I can get one more. Yeah. Okay, how do you do this?
Okay. Okay, so is the length of QR going to be 20 centimeters,
Yep.
and then can you just say they are mathematically? Oh, actually, no. I just do the width as well, don't I?
Mm-hmm.
And so the width will be like 25, and so do I need to then say? They're not mathematically similar because they don't have the same scale factor.
Yeah. So basically, like 25 divided by 15 isn't equal to 20 over 10.
Yeah.
Yeah. Great. Okay. So let's just go back. No. Don't need to worry about that. Let's see. Yes, so sometimes they make you do two transformations, and they say describe one transformation that does it. So rotation, you're okay for. Just try different points to see where the center of enlargement is. And try one if it's too high, go one lower, and so on. Let's see. So what would be this one?
So 90-degree, 180-degree rotation. And then center of enlargement.
Not enlargement, just center of rotation.
Center of rotation. Is it like so? Would it be like 2-1?
Yeah. 2-1. So rotation about 2-1 through that. Yeah. How about this?
So scale factor 4. And center of rotation.
Not rotation.
Center of
How would you find the center?
triangle Q. Would it be 6 across?
I'm not sure. You'll just join them up. And so center of enlargement.
Is it 0-1?
Yeah. And actually the easiest mark is missing. Yeah. That's it. So to find the center, you just join them up. Okay, so how about this?
Okay, so scale factor, enlargement, scale factor 3.
Yeah. What would you do?
And then is the center thingy 2, 2, 6?
I don't know. How would you find the center?
Do you need to start from one point and then go into the other?
Yeah, so just match up the corners. So for an enlargement, you just match up the corners. So where's the center of enlargement?
0, 1.
0, 1 is up here.
Oh, sorry. 1, 0.
Yeah, that's it. 1, 0. So I think what you're thinking of is center of rotation. Center of enlargement, you just join up the corners.
Okay.
It's not the middle point between them. And then the other one was where is it? Yeah. So for area and volume enlargements, you just find the scale factor, and for area times scale factor squared and volume times scale factor cubed. How was that for you, Andrey?
Tricky stuff.
Yeah, tricky. Good. And it's a shame that it's not easy for me to do it, on the computer. But so maybe just look at a video for it, and because they might have some like easy cheats or something for finding a -1/2 scale factor, quick ways. So continue this next time.
Yes, please.
And when is your first exam again?
First exam is on the 21st, so in about 3 days.
Okay, well, good luck.
Thank you.
All right, well done, Andrey. You did great, and look forward to talking again next week.